In this video, I'm going to show you how to find the missing side of a right triangle using the Pythagorean theorem. And I'm going to show you how to find the missing side of a special right triangles. And also I'm going to show you how to find all 6 trig ratio given a right triangle. Pythagorean theorem formula is going to be a squared plus b squared is c squared. Okay, so A and B are the side length of the two legs of a right triangle. So here you have A, and then you have B, and then C is the hypotenuse of a right triangle. Okay, let's take a look at the first example here. So here is to find the missing side. Okay, and then give your answer in simplest radical form. So you're given a right triangle and you're looking for the missing side, which is side x here. This is a right triangle given two sides. You can use the Pythagorean theorem to come up with the third side. Okay, so the Pythagorean theorem is a squared plus b squared is c squared. Now c is the hypotenuse. Okay, so c is 24 because it's right across from the right angle. Since a and b are the two legs of a right triangle, it doesn't matter which one you use for a, which one you use for b. Okay, so we can call the x to be a, and then the 22 is your b, and then your c is 24. Okay, we're going to solve for x here. So x squared plus 22 squared. 22 times 22 is 484. And then 24 squared here. I forgot to put the square there. So 24 squared is 24 times 24. That would be 576. And then minus 484. Minus 484. Okay, so x squared, and these are gone, add up to 0, equals to 92. And then we have to simplify it. So since x squared is 92, to go from x squared to x, you have to take square root of it. So we need to take square root of x squared, square root of 92, and this is going to give you x, and then 92 can be simplified. You can break up 92 using a perfect square. So here we can go 4 times 23, and 4 is a perfect square, so square root of 4 is going to be 2, and then 23. So your x is going to be 2 square root of 23. Okay, so this side here, x, is going to be 2 square root of 23. Now I'm going to show you guys how to find the missing sides of a special right triangle. Okay, we have two special right triangles. Okay, we have the 45, 90 special right triangle. The side that's opposite from the 45, those are the two legs. Okay, so the side that's opposite from the 45, so this is the leg, this is the leg, and this is the hypotenuse. So now if the leg is x, so if this is x, this is also x, well, this hypotenuse is always going to be whatever the leg is, square root of 2 longer. Okay, so that would be x square root of 2. So this is x, this is x, this is whatever x is times square root of 2. So for example, if this is 5, right, this would be 5, and this would be 5 square root of 2. If you know the side of the legs, okay, to get the hypotenuse, you times it by square root of 2. If you're given the hypotenuse and you want to come up with the size of the legs, instead of multiply by square root of 2, you would have to divide by square root of 2. Okay, so the other special right triangle is the 30, 60, 90. So for the 30, 60, 90, if the side that's opposite from the 30 degree is x, the side that's opposite from 60, it's going to be what x is times square root of 3. And the hypotenuse, which is this side right here, is going to be twice or whatever x is. Okay, so the shorter leg is the side that's opposite from the 30 degree, so that's going to be x. The longer leg is the side that's opposite from the 60 degree, so that's going to be whatever x is times square root of 3. And then the hypotenuse is the side that's opposite from the right angle, so that's going to be 2 times whatever x is. Okay, so for an example, if the shorter leg is 5, this is 5 square root of 3, and this is going to be 5 times 2, which is 10. Okay, so let's take a look at an example here. Okay, so here you have to find the missing side and then give your answer in simplest radical form. Okay, so the missing side we're looking for is going to be x, right, which is the side that's opposite from the hypotenuse. And then the other side is y, which is the side that's opposite from 60 degree. Okay, so you're given the side that's opposite from the 30 degree. That is going to be your shortest leg. Okay, so 5 times square root of 6 is going to be the shortest side. To come up with y, which is the longer leg, you would have to multiply that by square root of 3. Okay, so we're going to be 5 square root of 6 times square root of 3. And that's going to be 5 square root of 18. Okay, because 6 times 3 is 18. So that's going to be 5. And then simplify square root of 18 using 9 times 2. Okay, square root of 9 is going to be 3. So 5 times 3 is going to give you 15 square root of 2. Okay, so this side right here is going to be 15 square root of 2. Okay, so that's your y, 15 square root of 2. The hypotenuse is going to be 2 times the shorter leg. Okay, so that's going to be 2 times 5 square root of 6. Okay, so this is to come up with x. So x is going to be 10 times square root of 6. Okay, so the hypotenuse is going to be 10 times square root of 6. Okay, so let's take a look at another example here. So here we're finding the missing side given a special right triangle. This time it's a 45, 45, 90 special right triangle. The side that's opposite from the 45 is x. So we're looking for this side, and we're looking for the side that's opposite from the other 45 degree is y. Okay, and we're given the hypotenuse. So the 16 is the hypotenuse. So now if you know x and y and you want to find the hypotenuse, you would multiply by square root of 2. But because we're given the hypotenuse and we want to come up with x and y, instead of multiplying by square root of 2, you want to divide by square root of 2. Okay, so that's going to be 16 divided by square root of 2. It's just the opposite of multiplying by square root of 2. So according to this, you have to rationalize because you cannot have square root in the denominator. So to rationalize this, you would have to multiply by square root of 2 over square root of 2. Okay, so you end up with 16 square root of 2 all over square root of 4. And that's going to come out to, okay, so that is going to be 16 square root of 2 all over 2. And then 2 goes into 16 8 times. So your answer is going to be 8 square root of 2. Okay, so x is going to be 8 square root of 2. And then y is going to be 8 square root of 2. So this is 8 square root of 2, and then this is 8 square root of 2. So next I am going to show you guys how to work with trig functions. A trig function is a function whose rule is defined by a trig ratio. A trig ratio compares the lengths of two sides of the triangle. The Greek letter theta, so that is the Greek letter for theta, is used to represent the measures of an acute angle in a right triangle. Okay, so here's a special right triangle. So theta is this angle right here. So that means the A is the opposite side. Okay, and then the B is the adjacent side because it's right next to theta. And then the C is the hypotenuse because it's opposite from the right angle. Okay, so sine theta is opposite sides over the hypotenuse. Okay, so the opposite side is the A, and then the hypotenuse is the C. And cosine theta is adjacent over hypotenuse. Okay, the adjacent side is the B, and then hypotenuse is C. And then tangent is opposite over adjacent. So that means it's going to be opposite is A, adjacent is B. Okay, so there is a phrase that you can use to help remember the trig ratios of these trig functions. And that is SOHCAHTOA. Okay, so sine, S is for sine, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. These are your trig ratios of the given trig functions. Now the reciprocal functions are these functions. Okay, so cosecant is the reciprocal of sine because it's 1 over sine. Secant is the reciprocal of cosine because it's 1 over cosine. And then cotangent is the reciprocal of tangent because it's 1 over tangent. Okay, so that is going to be hypotenuse over opposite, because sine is opposite over hypotenuse. So this is going to be what? C over A. And then secant is the reciprocal of cosine. So that means it's going to be hypotenuse over adjacent, because cosine is adjacent over hypotenuse. So this is going to be C over B. And then cotangent is the reciprocal of tangent. Okay, so instead of opposite over adjacent, it's adjacent over opposite. Okay, so that is the same as, so adjacent is side B, and then opposite is side A from theta. Okay, so these are the ratios for the reciprocal trig functions. Okay, so let's take a look at an example here. So here you're given the ratio for cosine theta, and then find the remaining ratios. What you need to know for cosine theta, okay, so the ratio for cosine theta is adjacent okay, over hypotenuse. Okay, so that is going to be, it's given to you, it's 2 over 3, as you can see. So 2 is the adjacent side, and then 3 is the hypotenuse. So I'm going to do a right triangle here. So I'm going to call this angle theta. Okay, so that means this is adjacent. The side next to it right here is adjacent. This side right here next to theta, so that's going to be adjacent. So that's going to be 2. Okay, so the opposite side is here. Okay, so we don't know what this opposite side is, so we're just going to call it x. And then the hypotenuse is 3. In order to find all of these ratios, you need to know the opposite side. So here you're working with a right triangle. Okay, so you can use the Pythagorean theorem to find out the missing side, which is the opposite side. So the Pythagorean theorem is a squared plus b squared is c squared. Okay, so the adjacent side can be your a, and then the opposite can be your b, and then 3 is the hypotenuse, which is the c. So we can go 2 squared plus x squared is 3 squared. So here 4 plus x squared is 9. And then take away 4, take away 4. Okay, so these are gone. So I have x squared equals to 5. And then take the square root of it to go from x squared to x. So we take square root of x squared. And then we take square root of 5. So your x is going to be square root of 5. The opposite side here, so this is your opposite side, and that is going to be square root of 5. Okay, so now that you have all 3 sides, okay, you can fill in here. All right, so sine theta. So sine theta is opposite over hypotenuse. So that's going to be square root of 5 all over 3. Cosine theta is 2/3. We know that. And then tangent theta is opposite over adjacent. So that is going to be square root of 5 all over 2. Okay, so that is going to be 3 over square root of 5. And you have to rationalize this. So this would be 3 square root of 5 all over 5. Okay, you multiply top and bottom by square root of 5. Secant theta is the reciprocal of cosine theta. So the reciprocal of 2 over 3 is going to be 3 over 2. And then cotangent theta is the reciprocal of tangent theta. So this would be 2 over square root of 5. So when you rationalize it, you get 2 square root of 5 all over 5. Those are the remaining ratios. So the last thing we're going to get into is the trig ratio of special angles. Angles of 30 degrees, 60 degrees, and 45 degrees are used frequently in trigonometry. You can use your knowledge of the side relationships in special right triangles to find the values of the trig ratios. So these are the 2 special right triangles. So in a 45, 45, 90 degree right triangle, if the side that is opposite from the 45 degree is x, so this is x, this is x, this is whatever x is, times square root of 2. Now for a 30, 60, 90 special right triangle, if the side that's opposite from the 30 is x, the side that's opposite from the 60 degree is going to be x times square root of 3. And the hypotenuse is going to be 2x. So to be able to find the values of the trig ratios, you need the knowledge of the size relationship in these 2 special right triangles. Now we are going to use what we know here to find the values of the trig ratios. Okay, so the first one we're going to look at is sine of 45 degree. Okay, so sine of 45 degree. Okay, so you are going to need to use the 45, 45, 90 degrees special right triangles to find the ratio of this one. The ratio for sine is opposite over hypotenuse. Okay, so the opposite is going to be x, and then the hypotenuse is going to be x square root of 2, and then you can cancel the x, so you got 1 over square root of 2, and then you have to rationalize, so multiply top and bottom by square root of 2 to get rid of the square root at the bottom. So the answer is going to be square root of 2 all over square root of 4, okay, which is going to be 2. Okay, so square root of 2 over 2 is the value for sine of 45 degree. Okay, so let's take a look at the next one. So the next one we have sine of 30 degree. Okay, so we are going to need to use this right triangle. Okay, so 30 degree is here, so theta is going to be right here. So that means the x is the opposite. Okay, and the 2x is the hypotenuse. So we need opposite over hypotenuse. Okay, so that is going to be x over 2x. And then cancel the x. So you have 1 over 2. Okay, so sine of 30 degree is 1/2. Okay, the next one is sine 60 degree. Okay, again, sine is opposite over hypotenuse. So theta is 60 degree. So theta is going to be here. So that means this is your opposite. And it's over hypotenuse. So it's going to be x square root of 3 all over 2x. And then you take out the x. So your answer is going to be square root of 3 over 2. Okay, so this is the value for sine of 60 degree. Okay, so the next one we're going to look at is cosine of 45 degree. Okay, so cosine of 45 degree. Now cosine is adjacent over hypotenuse. Okay, you can use this to be your theta, or you can even use this one to be theta, okay, because they both are 45 degree. Okay, so if this is theta right here, okay, this is adjacent. So adjacent is x because it's right next to theta. So adjacent is x. And the hypotenuse is x times square root of 2. And then cancel the x. So you got 1 over square root of 2. It's the same as square root of 2 all over 2 after you rationalize. Okay, so square root of 2 over 2 is what cosine of 45 degree is. Okay, so next we're going to do cosine of 30 degree. Again, cosine is adjacent over hypotenuse. 30 degrees right here. Okay, so this would be your adjacent side. Okay, and the hypotenuse is 2x. And then you take out the x. So you're left with square root of 3 all over 2. Okay, so square root of 3 over 2 is cosine of 30 degree. Okay, so here, cosine 60 degree. Again, cosine is adjacent over hypotenuse. Okay, so 60 degree is right here. So this is theta. So that makes this the adjacent side. Okay, and then the 2x is the hypotenuse. So that's going to be x over 2x. Then you cancel the x. So you're left with 1 over 2. Okay, so cosine of 60 is 1/2. The next one we're going to look at is tangent of 45 degree. Tangent, the ratio for tangent is opposite over adjacent. Okay, so we're going to use the 45, 45, 90. So here's the 45 degree. Okay, so opposite and then adjacent. So that's going to be x over x, okay, which is the same as 1. Tangent of 45 degree is 1. Okay, so the next one we're going to look at is tangent of 30 degree. Again, tangent is opposite over adjacent. Okay, 30 degree is right there, so theta is here. So that means the x is the opposite side, and then this is the adjacent side. So you're going to have x over x square root of 3. Then you cancel out the x. You get 1 over square root of 3, which is the same as square root of 3 all over 3. Square root of 3 over 3 is the value for tangent of 30 degree. Okay, and the last one here is going to be tangent of 60 degree. Again, tangent is opposite over adjacent. Okay, so 60 degree is here, so theta is there, so that means this is the opposite side. And then adjacent is the x, so it'll be x square root of 3 all over x. And then you take out the x. You're left with square root of 3 over 1, which is going to be square root of 3. So tangent of 60 degree is square root of 3.